Throughout the 5-year Alternate Content Standards Professional Learning, our focus will be on improving our ability to implement the Dynamic Learning Map's essential elements. During our Fall and Winter Professional Learning, we use this graphic to show that when we use the partnership of high-leverage practices and evidence-based practices to teach the essential elements, it increases achievement for students with significant cognitive disabilities. Let's start with the essential elements. As we have learned, the Dynamic Learning Map's math essential elements are arranged into 4 claims. For our spring professional learning, we will focus on Claim 4, Algebraic and Functional Reasoning. In Claim 4, there are 2 math conceptual areas that we will be exploring. Today, during Segment 1, we will focus on the essential elements for Math Conceptual Area 4.1. Use operations and models to solve problems. Tomorrow, we will focus on Math Conceptual Area 4.2, Understanding Patterns and Functional Thinking. These are the essential elements that are under the Math Conceptual Area 4.1. As you can see, there are no essential elements identified for 5th grade. To determine what skills to teach, you can use the linkage levels from grade 4 and 6 to identify skills in 5th grade. Remember that the linkage levels help to identify the initial, distal, and proximal precursor skills that come before the target skill or the successor skill. As we have previously seen, there are gaps in the progression for some grade levels because an essential element represents the essential core or big idea of the college and career readiness standards. The essential elements address a small number of content standards representing a breadth but not depth of the coverage across the entire general education standards framework. Looking at your feedback, we want to make sure that you know where the resources are in Schoology so that you can use them on a regular basis. Under Beyond the Session Resources in Schoology, you will find a folder for the Dynamic Learning Map's essential elements. When you click on that, there is one for Math Essential Elements by Domain. This first PDF will give you all of the essential elements for math. Then you have Claim 1 and Claim 4. If you click on Claim 4, and then on this link, you will get the same chart that I had on my screen earlier. The claims that we've created here just are to be able to help identify the what to teach, including the grade level progression for you. Before we dig too much further into the essential elements from Claim 4, it's helpful to review the essential elements from Claim 1 number sense that we discussed in the winter. As you can see from the graphic on my screen, the essential elements from Claim 1 number sense, such as counting and cardinality, are the foundation skills needed for students to be able to achieve more complex math concepts that are found under the algebraic and functional reasoning claim. According to Van de Waal, Karp, and Bay-Williams, algebraic thinking or reasoning involves forming generalizations from experiences with number and computation, formalizing these ideas with the use of meaningful symbol system and exploring the concepts of a pattern and functions. We are going to watch a short clip from the Dynamic Learning Maps. As you watch, think about what the algebraic thinking means for students with significant cognitive disabilities. Please pause this recording to watch the video. I'm now going to show you how to use a free Google digital tool called Jamboard. Jamboard could be a helpful digital tool when you're teaching your students virtually. I'm going to show you how to use it, and then you're going to try it on your own. The video had us starting to think about algebraic thinking. We are going to determine if the Post-it notes belong under box 1, examples of algebraic thinking, or under non-examples of algebraic thinking. Remember, algebraic thinking and reasoning involves forming generalizations from experiences with numbers and computation, which were a lot of the essential elements from Claim 1 number sense. The first one I have here is What is 2 plus 5? I know this is not an example of algebraic thinking, so I'm going to click and then drag it under Non-Examples of Algebraic Thinking. Below the Dynamic Learning Maps video that you just watched, you'll see a link to Jamboard. It will prompt you to make a copy, and you're going to determine if the rest of these post-it notes are examples of algebraic thinking or non-examples of algebraic thinking. Pause the video to complete the activity. When you have finished, please resume the video to check your answers. If your Jamboard looks something like mine, then you are correct. We have 3 non-examples and 3 examples. Let's start with the non-examples. We have, can you count to 10? What is 2 plus 5? And what number is this? All 3 of these are very important skills, but they're foundational skills that students need to be able to master before moving on to more complex skills. Over here on the examples of algebraic thinking, let's look at how many more objects do you need in this set to make these 2 sets equal. There are a lot of skills that a student needs to be able to demonstrate to have this answer this more complex essential element. For example, the student must be able to count with meaning, compare sets of objects using the vocabulary of equal, and also create sets. So this gives you an idea of how the foundational skills then move on to teaching students more complex skills. We have now come to the end of this section. At the bottom of your page, please proceed to 1.3 High Leverage Practice 14.